Hello everybody, welcome to today's lesson. This is a very exciting topic, unlike anything we've talked about before thus far. This is the topic of nucleonics, radioactivity, and radioactive decay. And so to begin the topic very briefly, I will tell you about the two major kinds of nucleonic reactions that happen. There is fusion and there is fission. Fusion, like the name implies, is the binding of two or more nuclei to form a new nuclei and a new element. Okay, and this occurs, does anyone know where? This occurs on the sun. So fusion on the sun happens by hydrogen combining to form helium, and an outstanding amount of energy is released. Very, very big amount of energy. The other general category is the exact opposite of that. Instead of building up something, instead of fusing together, we have fission, which is the breaking up of something. And that is mainly what we will talk about today. We can cultivate those reactions here on Earth, and we do with some success, except for Chernobyl, that we will talk about soon, and we can harvest large amounts of energy from them. All right, let us begin. So here are just some words you should be familiar with, terms fluorescence and phosphorescence. I'm sure you've heard of these before. Fluorescence is the emission of light when exposed to some exciting energy. Okay? And phosphorescence is the emission of light after exciting energy is already removed and it still phosphoresces. All right. And now let's get into it. So the nature of radioactive emissions that we will talk about today. There are three main categories, plus two more that we will talk about, but these are some of the main ones. So we have alpha particles being released, beta particles, and gamma rays. All right. And also, I should preface this with a little bit of history. There was a very, very famous scientist. Actually, it was a husband-wife team. Their names were Pierre and Marie Curie. They discovered radium, actually, which is very exciting. They worked with radioactivity their whole life. The man died in a tragic accident, and she actually received Nobel Prize, but then she died from radiation poisoning. All right, but they discovered a lot, so very good for them. But let us get into the meat of it. So first of all, what is an alpha particle? You might have heard of it before. An alpha particle is a helium atom without the electrons. Take a look at your periodic table. How many protons does helium have? That's right, it has 2, right? So it has a +2 charge if you don't have any electrons. And that is exactly what an alpha particle is. An alpha particle has the weight of 4. Why is that? 4 AMU, or grams per mole. It is because it is composed of